Hello class, and welcome to our first lesson on forces. In this particular lesson, we're going to be focusing mainly on the difference between a balanced and an unbalanced force. So our learning target is I can explain the difference between balanced and unbalanced forces. The standard that we're looking at, it states demonstrate the effect of balanced and unbalanced forces on an object in terms of gravity, inertia, and friction. We're going to first discuss the difference between balanced and unbalanced forces in this first lesson, and in the next lesson we will talk about the other terms listed in this standard. First of all, what is a force? Well, a force can be a push, or a force can also be a pull. So a force is a push or a pull. Forces have size and they also have direction, and we use the unit of Newton in order to express these different forces. So when you see the amount of force written or the measurement for a force written, it will always be expressed with a capital N, which is short for newtons. And it's just indicating the amount of force that's being applied to an object. A force is always exerted by one object on another object. Forces come in pairs, and they can either be balanced or unbalanced, which is going to be the basis of our lesson. Let's first talk about balanced forces on objects. When two forces acting on an object are equal in size but are opposite in direction, we say that those forces are balanced. Balanced forces do not cause a change in the motion of an object. So you would say an object is not accelerating, for example, if there are balanced forces acting on an object. There is no change in the motion. Let's look at this first example. This is a basic example of balanced forces acting on an object. You have a toy car and you have two people that are pushing on the car with the same amount of force, but in opposite direction. Therefore, the truck will stay still. These arrows, whenever you're looking at force diagrams, there's always an arrow, and the arrows will indicate the amount of force that's acting on the object. If the arrows are of the same size in opposite directions, then we say that the forces acting on that object are balanced forces. And sometimes these arrows will be accompanied by a number, and sometimes they won't be. But you always want to look at the size of the arrow, okay? The same size would just mean that the forces are balanced on that object. Let's look at another example. The ship is floating on the water. The forces are balanced. Which forces are acting on the ship? Take just a few seconds and think about what forces could be acting on this ship that's causing it to stay afloat. If you said one of the forces is gravity, then you are correct. Gravity is a force that affects all objects on Earth. It always pulls objects towards the ground or towards the center of Earth. So gravity is definitely a force that's pulling the ship down. And then you also have the upward force of the water that's keeping it up. So since these forces are opposite directions but same size, therefore the boat will stay afloat. Let's look at another example of balanced forces. The vase is resting on the table. It is not moving. Therefore the forces must be balanced. Which forces are acting on the vase? Take a few seconds. If you predicted gravity is a force that is acting on the vase, you are correct. Gravity, of course, is pulling the vase down, and then you've got the upward force of the table that is pushing, keeping or holding the vase on up. Excuse me. There are several objects around the classroom that will have balanced forces acting on them. So just take a look around the classroom and see if you can pick out a couple of objects that would have balanced forces acting on them, and think about the balanced forces that would be acting on these objects. Let's now switch gears and talk about unbalanced forces. When two forces acting on an object are not equal in size, then we say the forces are unbalanced. Unbalanced forces will cause a change in motion by changing the object's speed or direction. So when objects are accelerating, which is something we learned about in the previous lesson, then we say that there are unbalanced forces acting on that object, causing the object to accelerate. And remember or recall, there are three ways that an object accelerates: speeding up, slowing down, or changing direction. So if one of those is happening, then that means there are unbalanced forces that are causing that particular object to accelerate. If you look here at the picture, you can see that you've got a bigger force behind the truck, a smaller force in front of the truck. So the truck is going to speed up in the direction of the bigger force, which would be forward. Let us now look at another set of examples for unbalanced forces. Let's talk about this one first. The man and the parachute are slowly falling to the ground. Which forces are acting on the parachute? Which force is bigger? How can you tell? Take a few seconds. Of course, we know that gravity is definitely one of the forces that's going to be acting on this object. We also have the force of air resistance, which is created by the parachute, which is pushing upwards. Okay, the air resistance is pushing upwards on the parachute. However, look at these two arrows. You can clearly see that gravity is the bigger force. So we can tell this because the direction of movement of the man and the parachute is the same as the direction of the force of gravity. Objects will always move in the direction of the larger force. And in this case, the man is falling to the ground because gravity is pulling him down, which is bigger than the force of air resistance. Let's take a look at another example. You have paper clips are jumping up to the magnet. Which forces are acting on the magnet? Which is the greater force? Of course, we have the magnetic force, which is pulling the paper clips upward, but you also have the force of gravity, which is pulling the paper clips to the ground. However, in this scenario, you can clearly see that the bigger force is the magnetic force. The magnetic force is greater than the force of gravity, therefore the paper clips will move in the direction of the biggest force. So whenever unbalanced forces are acting on an object, that object will always move in the direction of the larger force. Let's take a look at some more examples. Okay. Here you have an elephant that is falling to the ground, but this time there's no parachute. So there is much less air resistance. You have gravity that's pulling the elephant to the ground. And then of course you do have air resistance that's pushing upwards. Not as much as we had with a parachute. There's going to be less here. Gravity still is a bigger force. Because there is a bigger difference between the force pulling downwards and the force pushing upwards, the elephant will fall much more quickly than a man with a parachute. So the man with the parachute was falling much slower because of the force of air resistance, but that's not the case with the elephant. The elephant will fall to the ground much more quicker. But in this scenario, it's still going to be the force of gravity that is the bigger force. All right. Another example for unbalanced forces. You've got two men arm wrestling here. Which arm wrestler will most likely win? Which direction will both arms move? Well, remember I told you that anytime you have arrows of different sizes, that means that there are unbalanced forces acting on the object. And we can clearly see that this man in the blue shirt is applying a much larger force. Okay, so the direction of the forces is going to be, excuse me, let me go back. The direction of motion is going to be in the direction of the larger force, okay? Which in this scenario is going to be to the left. Okay? Now let's look at another example of tug of war. Which direction will the rope move? Now in this scenario, we have arrows, but we also have numbers. It indicates the amount of force. This character is pulling with 4 newtons. To the left, this person or character is pulling with 10 newtons to the right. The direction, of course, is going to move to the right because that is your larger force. All right, let's look at our final example here. You're looking at a diagram below. You've got 2 women are wearing ice skates. If they both push off from one another, which woman will most likely move the farthest and why? Well, you have Jennifer that weighs 175 pounds and you have Julie that weighs 130 pounds. Take a few seconds to think about which one of these women are going to move the farthest and why. All right, if you said Julie, you would be correct. Julie is going to move the farthest because Jennifer's push will most likely have more force. So she's going to have more force. So when they push off from one another, Julie is going to go a little bit further because Jennifer is going to be pushing with more force because she has more weight. Let's do a quick review of some of the concepts that we've learned about in this lesson. There are many different forces which act on an object, such as gravity and friction. If forces are balanced, the object doesn't move. If forces are unbalanced, the object will do one of the following things: begin to move, stop moving, or change direction, or speed up. Okay? Or it can slow down. So basically, if forces on an object are unbalanced, the object, you could say, is going to experience acceleration. Okay? It will begin to move, stop moving, or it will change direction, speed up, excuse me, or it will slow down. Also, if forces are balanced, if the object doesn't move, but if the object, you can have balanced forces acting on an object, and that would just mean that the object is not accelerating, because we did talk about some scenarios of objects that could be traveling at the same speed and in the same direction, and you could say that the forces acting on that object are balanced. But typically, the forces on an object that's not moving are going to be more balanced than forces on objects that are moving. That brings us to the end of our first forces video lesson. Please make sure that you have filled out all of the information on your graphic organizer.